this video provides guidance on the homework related to portfolio model. We use a case, so we selected a fund called Barron Partners Fund Retail Shares, and I have provided some reports for this fund, and you can refer to those reports for completing some further questions in 6th and 7th year. But before that, we need to calculate the optimized portfolio or the efficient portfolios and construct the efficient frontier. And that is a pure technical problems. So we'll go from question 1 to question 5. So starting from calculating returns and finally calculate the efficient frontier. Now let's start. So I have incorporated some information about this fund already. So this is their Morningstar rating. So Morningstar rating is based on its past performance mainly. And its expense ratio, that's also one of the key indicators or the key characteristics for the fund, that how much the management team would ask for compensation, their work, compensation for their work from the investors. And also another thing about the fund, especially mutual fund, is to look at their category or investment style. So back in 2019, I think this fund is still a mid-cap growth fund. So it's within that category. But I think in recent days, they changed their investment style, and we can talk about it later. So this is the reason I picked this fund is because they have really good performance, and maybe we can learn something from their portfolio construction back to 2019. So we can start from the price data. So required by the SEC, all the mutual funds should report their top 10 holdings. So it's not hard to find a top 10 holding for the mutual fund. You can find it from Yahoo Finance. This is just a screenshot of Yahoo Finance, but you probably cannot see it now because this is the data in 2019. But if you have access to, for example, Morningstar and other database, you'll get the historical holdings of the mutual funds. And of course, if you know how to calculate a portfolio using mutual fund as the case, and then you can also extend it to other type of funds, for example, hedge fund, ETFs. So those are all natural extension. So after I know all of these holdings means the assets they invested in. So there are top 10 holdings here, but we only have 9 returns because one of those firms, SpaceX here, is a private firm. So without any further help of knowing the 11th holdings in this portfolio, we probably cannot get a portfolio of 10 stocks. So instead, we're going to use portfolio of 9 stocks here. And the final column here is the price for S&P 500 index. And you can also use, instead of using the index directly, you can also use SPY, which is the ETF tracking the S&P 500. So we get all of these. So I download this from Yahoo Finance, I believe. So this is roughly 1, 2, 3 in 3 years return, 3 years prices. So question 1, let's go back. Question 1, we need to calculate return and standard deviation, variance, and beta for each of the assets. So we need to get this starting from return. So we will use the log return. And then calculate return. Return is just the mean return equals to average. Variance is the sample variance. Standard deviation is the square root of variance. Beta is the slope of the market model. So for the Y's, it should be company's return. For the X, it should be the market return. So it will be always market return for X. So I'm going to fix it. you calculate everything correctly, the beta for the market themselves is just 1. So we're going to see here that Tesla is slightly lower. We have here, these are slightly higher than the market systematic risk. So then we can continue to question 2. So question 2 here, we want to calculate the variance covariance matrix first, and then calculate the minimum variance portfolio. So for calculating variance covariance matrix, you can use the formula. I would prefer to use the VBA code just to save some time. The VBA code, I think it's in chapter 8 slides. So copy. And paste. So the name of this user-defined function is called variance covariance. And basically in this code, it defines I and J. I think I here represents column and J here represents row. So it will calculate here, the number here, all the way to all these cells here in the same row, and then move to the next row. So these are I equals to 1, I equals to 2, 3, 4, 5, 6, 7, 8, 9. And then the J here is still equals to 1. So the next row, J equals to 2, and here I equals to 1. So all the way here, and then to the next, starting from the next row. So it calculates based on these. This is a loop. So it will go from here, the first row, and then to the next row, and then to the next row, all the way to this I equals to 9, J equals to 9. And then for each of this cell, it will utilize this variance covariance function in Excel. As you remember, this application dot worksheet function will call for covariance function, which is here. Okay, you can change it to covariance dot s, doesn't really matter. Will produce the same method. So we can just go ahead and start using the code. Okay, what should be input in the code is a range. So the range is basically the returns. So we need the return of all these 9 different stocks. Equals, I'll find the user-defined function here, variance covariance, and the return data is here, all the way down and all the way here. So let's see if what happened if I include column K. We don't really need column K here. Okay, it shows error of spilling over to the last row, last column here. So let me just change it to J. Okay, good. So the next one, we need to calculate the correlation matrix, and it's here. Again, this code is very similar. It just utilizes the correlation function. So correlation function here. So this is the correlation function, returns the correlation coefficient between 2 data sets. So it only calculates the correlation between two data sets. That's why here we need to write a loop. So each time it only calculates the correlation between I and J. So we're going to use a loop to define I and J each time. So as Excel to run it over and over again, starting from here, I equals to 1, J equals to 1, and then all the way here for the first row, and then the second row, and then the third row, all the way finally to here, I equals to 9, J equals to 9. So here, what we need to input is still the return. So we need the return to calculate the correlation and coefficient. Equals correlation matrix. Enter. So for the correlation, it has a nice structure. Actually similar here for covariance matrix. They are symmetric. So the value here, the correlation between Tesla and here, the name of this stock is called CoStar Group. So the name of CoStar, the stock of CoStar Group and Tesla here, the coefficient is 0.0037, possibly correlated. And here in this cell, it also shows the correlation between CoStar and Tesla. It should be the same because, you know, correlation IJ equals to correlation JI. So these should be the same, and same here. These two are the same, these two are the same. So they are symmetric. So sometimes we don't really need to show the lower side of this matrix. That's why, therefore, we have another code to just show the triangle. So here, the ASIC cells only calculate the correlation coefficient where I is less or equal than J. So only when, so I here, so I is here. If it's less or equal than J, so all these, so J equals to 2 here, 3, 4, 5. So these will all have values. So the cells here will all have a value. But here J will equals to 1, but I will equals to 2. So there will be no value here, but the value will start from the second column. And for the third one, I equals to 3. So here J equals to 1, J equals to 2. So these two cells will not have any value. So therefore, if I is less or equal to J, calculate the correlation, else only output nothing, and this if statement. Okay, this if statement is under the loop. So then execute. So this next is together with this for statement. Okay, let's use this user-defined function called correlation matrix triangular. Enter. Okay, so these cells here where I is greater than J, Excel will not calculate the correlation coefficient. So then for a global minimum variance portfolio, let's go back to the slides. It's the minimum portfolio on the efficient frontier. So efficient frontier offers us the best combination between risk and return. And among all of these available best combinations between risk and return, one of them offers the lowest variance. And that is this point. And we now want to calculate this global minimum variance portfolio. So to calculate that, we can directly use the formula. And the formula is given by here. To utilize this formula, we need to have one VBA, or we need to at least have a vector, a row vector with all those columns, with all those cells equals to 1, and a column vector with all those cells equals to 1 as well, to get this to basically input this formula. So one thing you can do is you use the VBA code to generate these. Another thing you can do is manually input one as one row and one in all of those ones in just one column. So I'm gonna utilize the VBA approach first, and then I can illustrate how to use it manually. Okay, so this will produce unit row vector, this will produce unit column vector. So I actually need this here. So let me just show you. We need n unit row, we need n1 in this row. So here the n equals to 9. So therefore we need unit row equals bracket 9. So that will produce one row, but with 9 different cells. And all of those cells has a value equals to 1. And then let me utilize unit row column. I also need 9 different ones here. So I have 9 cells, and all of those cells has a value equals to 1. So that's this meaning. So one row, so unit row vector is here, unit column vector is here. And the S matrix, we already have it. S minus 1 means S inverse. So I'm going to use these equals. So I'm going to input this formula. So first, let's deal with the numerator. So we'll need to use matrix multiplication and unit, or we can use these unit row, comma, and we will need to inverse this matrix, M inverse. So that is the numerator divided by the denominator here. And matrix multiplication So unit row vector again, and inverse variance covariance matrix. And comma, unit column vector, bracket, and enter, and you're going to see an error here. This is because by using this formula, the output will be a row vector. So it will be output in one row. Here, we want the output to be in one column. So therefore, I can just first show you the output. I copy everything here. So the output is in one row, right? So how to fix it? Because we want to do everything in one step, just to output everything here. So let me just copy it back. So I think I can just directly transpose it. There are a lot of ways of doing this, okay? I can transpose it here. Okay, good. Another way I can do it is I can directly here input unit row vector, bracket 9. Same here, unit row vector, bracket 9. And this should be unit column, bracket 9. Enter. So then I can clear everything here. Equivalently, since these are all matrix, here this is 9 by 9 matrix. Here this is a 1 by 9 matrix. So therefore, the numerator will be 1 by 9. In the denominator here, this is 9 by 9, 1 by 9, 9 by 1. So the numerator will be just 1. So if we want to basically so therefore this output will be 1 by 9. So if we want to make the output to be 9 by 1, so I think we can do 9 by 9 times 9 by 1. And then here, we use 9 by 9 times 9 by 1. So here, this is 9 by 1, and we just need to divide it by the same thing here. This should be the same. So here, this is 1, so that will be just 9 by 1, okay? So let me just switch this, change the sign, make it to 1 column in this case, and then cross this. I'll copy everything here. Okay, move this box here. And what is this value? Oh, okay. This is M inverse. Okay, M inverse. Here, I will move it and change it to column. Enter. Okay, we don't need transpose. Okay, good. So here, you can just either use this transpose or just use the formula here. Okay, these two formulas should give you the same result. And the next thing is we can calculate the mean. So to calculate the mean, there are a couple ways. So we have what we have here, the return is here in one row. So we can do matrix multiplication, comma, go back here, enter. And then for the calculation of variance, okay, to calculate variance, let me go back to the formula. So this is return. So formula is here. Okay. This guy here. So we need to use x transpose times s times x. So equals matrix multiplication, and x transpose. Now, our x here is in one column. That's good. We need to transpose it. So S matrix, good, close the bracket, n times here again, enter. So square root of the variance equals to sigma. Okay, going to the next one. For next, we will need to calculate the efficient frontier with no constraints. So we'll not put any constraints here at this stage, and we'll need to make a graph. The requirement of the graph is not just showing the efficient frontier, but also we need to show the individual assets and mark the point for S&P 500 index. So this can be considered as the market portfolio. So we can go ahead and start calculating efficient portfolios based on these stocks available. So there are 9 stocks here. We can do this formula here. Equals matrix multiplication S inverse and return minus constant. So that's the numerator. Denominator here is the sum of S inverse. So matrix multiplication again. S inverse times return minus C. Same here. So they should sum up equals to 1. And to calculate portfolio mean equals, we can do matrix multiplication, and another way is to just use sum product. For sigma, same here. I'm going to copy the formula. And take the square root. For theta, which is the Sharpe ratio, if it's Sharpe ratio, the interpretation of C will be the risk-free rate. If it's beta, then we can just think it as return minus the constant divided by the sigma. So these are just 2 examples of efficient portfolios. And we want a frontier. We want all possible combinations. So therefore, we need to find an efficient way of producing efficient frontier. So here, based on our proposition 2, if we know two efficient portfolio, which is portfolio X and Y here, then we'll know all other efficient portfolios. All other efficient portfolio is just the convex combination of X and Y. So we just need to manually vary this lambda here and construct a third, a fourth, all these different portfolio using different lambda value. So we got a lot of different efficient portfolio, and then we can put them all together and make the graph. So here we need to calculate the portfolio variance. We need the covariance between X and Y. So the covariance between X and Y will be given by the slice. Here, the covariance between portfolio X and Y equals to here X inverse, X transpose, so equals matrix multiplication, transpose. I think I need to add a matrix multiplication here, one more, since there are three values. So transpose of X times variance covariance matrix times Y. So enter. Here for return, since there are only two values here, so we can use the formula directly. So by using the formula directly, I'm saying using this formula directly, use X times return of X plus XY times return of Y. So we'll get here. So the lambda will be the weights that we use. So which is 0.3 here. We're going to vary this 0.3 later, equals lambda times portfolio mean plus 1 minus lambda times the mean of Y. And the portfolio sigma here equals to the formula here. So equals square and times variance plus 1 minus 0.3, which is 0.7 square times sigma square plus 2 times weight times the weight of Y as well, which is 0.7. I'm not going to hard code 0.7. Instead, use 1 minus 0.3 and times this sigma ij means covariance. Enter. So sigma here, which is the standard deviation, will be just equals to the square root of variance. So we need to produce a data table so that we don't need to manually calculate all of those other efficient portfolios. Equals sigma here equals the mean, produce a data table. So these are just the proportion of X. And I'm using 0.3 to calculate 4% and 2% here. Okay, so that completes this part. And it's not the end yet. We need to do the graph, make a graph. So here, I put everything here already. I put all the data that you're going to use. It's referring back to the data table here. So these are just the data table. And these are the return. I transpose it. The original one is in a row. So that's why here you see a transpose function. And the SMP here is also coming from the numbers that you calculate in previous questions. So then you can just go ahead and first insert scatter plot. So this will be the efficient frontier. And we need to add individual assets. So since they are individual assets, we don't really need something to connect them. Oops. And we can also show the data point. So they are all within the efficient frontier. That means all the portfolio here, they are optimized. And one last thing is to add this SMP. Let me see if I could just drag it. Okay, the SMP is here. I want to add a special label to it. So here, this is the SMP. Okay, so I can move on to the next question. Next question is question 4. So question 4 here, we try to add some constraint. The efficient frontier showed it here. These are efficient frontier without constraints. So you're going to see in some cases, you may need to short sell. So here, mutual fund, they do not really, you do not really often see that mutual fund engage in short selling. That includes short selling equity stocks. They may sometimes borrow money from the treasury, but short selling stock is not something that they will normally do. So therefore, we want to add this constraint. So we're going to utilize the solver in Excel to solve for the maximized weight here instead of using equations. So using equations, it's very hard to add those constraints. We can just simply use the tool in Excel to add a constraint and also maximizing the theta. So we're going to need to report under constant equals to 0, what is the mean sigma theta, and then modify the VBA code to produce the purple table and report mean sigma Sharpe ratio of comparable efficient portfolios and the current portfolio. Compare the holdings. So let's do the first thing. So assume the constant equals to 0% and calculate using solver to calculate optimal portfolio with no short sales. So not allowing for short sales. So that means all these X should be greater than 0. So to use solver, I need to input some value first. And I need to have this cells with function with formula. So adding all them together. So the sum of all this will be another constraint. The sum of all these weights equals to 1. So now we just need some formula here, but later we're going to specify it in the solver. And then we calculate the mean here. This is also necessary to have all this formula input here because we're going to use the theta. So theta will use the mean and sigma to calculate theta and also the constant. So sigma is also here. So to make sure everything will work properly, we're going to have constant here inputted as a hard-coded number. And then first input some initial value for Excel to search for. Like Excel will do this like try and error method. So when we are learning, letting Excel to search for internal rate of return, when there are multiple internal rates of return, Excel needs a guess. So this is the guess point, like the starting point. And then we also need, this is related to our constraint. It's not the use of solver, but our constraint here, if you look at the slides. So our constraint here is the sum of X equals to 1. And if we want to add further constraint, then we'll add x is greater than 1. I think that is for chapter 12. Okay, and then we can go to data, solver. So make sure everything is correct here. So our objective is theta. So theta is B32, that's great. Maximize theta, like it is shown here, maximize this slope of this curve to find the tangency point. So the tangency point will be an envelope portfolio. So then what Excel can do to maximize this theta is to change the value of x. So we're going to let Excel know these are the value of x that Excel can change. And the constraint here, so the constraint here is first adding all this x together equals to 1. So this is one constraint. Another constraint is to make these variables non-negative. So make all of this x variable non-negative. Or you can just click solve here, okay? That's one way to specify the condition. Or you can add, okay, here, these should be greater than 0. Okay, so we have two constraints here and solve. Okay, good. So we can compare this. So when constant equals to 0 without any constraint, we will have negative, so we need to short sell x, 3, x4, x6, and 8. So 3, 4, 6, and 8. Now here, with constant equals to 0, 3, 4, 6, and 8 cannot go beyond 0. So it cannot go negative. So they become 0 here. And this, adding them together, it equals to 1. So good. So the next step is to, now you can basically record this number and then answer question 4A. So next one is to use VBA codes to calculate efficient frontier with no short selling. So remember, efficient frontier is calculated by varying this C and then finding all this. So these are all different tangency portfolio under different value of C. So you will come up with a frontier like this. So without any constraint, we have proposition 1 and 2, so that we can, regardless of the choice of C, we can just use portfolio X and portfolio Y, assuming that given that portfolio X and Y, they are efficient portfolio, then we don't need to do the whole process. So we can just generate portfolio C, D, E, F, G, multiple portfolios based on X and Y. But in this case, we don't have proposition 1 and 2 again. So we have one more constraint. So we're going to strictly follow this and use solver to solve each of this tangency portfolio. So we're going to ask solver to solve the problem of maximizing theta such that the sum of x equals to 1 and adding another constraint, each of this x is greater or equals to 0. And ask solver to solve this problem by varying the C. Okay, so each row here will represent a different C value, and each row here will represent one tangency portfolio that maximize the theta. So that's the idea. We're gonna ask Excel to run the solver row by row. So we're going to write a VBA code. So I provided the VBA code. There is one short VBA code in the lecture slides of chapter 12. So scroll it all the way down. So copy. Now we need to modify it. So these are not user-defined function. So these are called subroutine. So here it calls Excel to use the solver. So to add solver in VBA, we need to do in tools, references, and enable solver here. Okay. So we have reference here so that solver can be used under this VBA setting. So we're going to have solver, and this is related to everything here. So maximize B19. So maximize not B19, but 32. By changing B19 and 27. So next is the constant. So we need to change the constant from minus 75 to 2.75. So here count equals to 1. Here count equals to 1. Here count equals to 35, I believe. So there are, yes, total of 35 rows here. Yes. And increase every time by 0.0025. So we're going to need the code here. So we need to solve for this intercept. So we do not know this intercept here, but we know when count equals to 1, the y value equals to minus 5.75%. So we can basically use the y value minus here. Okay, so that equals to 10.75. But we need to change the slope as well. So the slope will be the number that this constant will increase for each row every time. So that will be 0.0025. So increase 0.0025 every time. Okay, yes, that's minus 6%. So we need minus 6% and change it to 0.0025. Can do 35 column. And the next thing is to adjust here. Now these are all, so here we define a range called result. In result, we will call the sales call constant, call the sales call portfolio sigma, and these are all defined in our original Excel. So our original spreadsheet here. So these are all properly defined. So constant is defined here. Portfolio mean is here, sigma, and the result is the table here. X1 is here, X2, X4. If you want to add more, so say if you have a portfolio of 10 stocks, you want to add more, you add a row here, add a row here, add a column here for the 10th, and also you need to define the cells. So rename the cells. So name X-10. Here for the same here, you need to modify in the VBA code. So we need a couple more. So 4, 5, 6, 7, 8, and 9. Okay, so we need to ask Excel to calculate here. First use solver. And then the constant is the constant will change each time under this loop. So from 1 to 35, and it will produce the constant equals to minus 5.75 and all the way to 2.75. So counter equals to 35 times this 0.0025 minus 0.06 equals to 2.75. So each time run this, we'll have a different constant and use under different constant, we're going to produce different portfolio sigma, portfolio mean, so that we can maximize B32. B32 is here, maximize the theta by changing here, X1 to X9. And this code here is to just to output X1 and X9 calculated here to result. So result is defined here in this purple table. Okay, good. So next is to run this code. So I can just press Control A. Doesn't work here. Let me just try here. I see. The Excel only calculates the first 4. Wait, I think that's because I did not change the value here. So it goes from 1, 2, 3, 4, 5, 6, and then 5, 6, 7, 6, 7 here again. So so starting from 5, there are some error here. So I need to wait until we finish calculating everything and change the code. Okay, I'm going to change the code here. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, run it again. Okay, everything looks good here. So no errors. Looks fine to me. Let me just make it to a percentage. So then we can continue to the next question here, question C. Find comparable efficient portfolio based on similar level of return and similar level of risk as the current portfolio. So our current portfolio is given by the snapshot here. So I input some of those here already. So here for Charles Schwab Corporation, that's 5.06. So equals to 0.506 and 4.85. So 506, 485, 506, 485. Good. So I want to convert it into one whole portfolio, assuming that all of those assets are these 9 different stocks. So now it only consists 88% of the current portfolio, but since we don't have information for all other holdings in the fund, so we're going to assume that these 9 different stocks are all of those holdings. So I will need to convert it. So adding the sum of all these equals to 1. So therefore, we're assuming that we're only holding these 9 stocks. In reality, this portfolio, this mutual fund, has more than 9 stocks. I'm going to show you in the Excel file later, so you'll also see it. So the portfolio here is just one part of their holdings. So now we need to first calculate the portfolio mean and sigma for this current portfolio. So we're going to assume that the current portfolio has the weights for each asset here in this column. So it equals, okay, I think we can just copy the previous formula. So Sharpe ratio, we're going to use the real definition of Sharpe ratio using the risk-free rate. So use mean minus risk-free rate divided by sigma. So the Sharpe ratio equals to 0.38 here. So find comparable efficient portfolio based on mean. And here find comparable efficient portfolio based on sigma. So the graph here already shows that this is the efficient frontier. It actually plot everything here. And the current portfolio is here. So with 4.58 sigma and 1.83 return. Now there are 2 comparable portfolio. One is the portfolio with same level of return, but offer lower variance. And another portfolio is the portfolio offers same level of sigma or standard deviation or risk, but with higher return. We're going to find these two portfolios. So first, comparable efficient portfolio based on mean. So let's find the same mean. So mean here for current portfolio equals to 1.83. So let's find mean here equals to 1.83. So you're going to see one of them is here. So that's the closest we can find. So I'm going to highlight here, and portfolio with similar sigma. So sigma here is 4.58. So the one with 4.58 sigma, that's the most similar one is this portfolio. So we can basically refer this weight here. I'm going to do transpose. So from X1 to X9. And here, transpose. So are they underweight or overweight? This is a comparison to the current holdings. So if here is greater than this, then this is overweight. Otherwise, okay, I think it should be the other way around. So underweight, overweight. So if the efficient portfolio here is the weights were calculated by portfolio optimization, if this weight is larger than this weight, then we are saying that the current portfolio, the weight for CoStar is underweight. And for Tesla, the efficient weight will be 0.1, so roughly 10%. But actually, this mutual fund holds roughly 19%. So it's currently overweighting on Tesla. Okay, if the calculation here is correct, that should equals to the things here. So this is 0.17, 0.17 here for sigma, 1.85 here for return, 1.85 here for return. So that's good. And here, 4.53, 4.53, 2.16, 2.16. Is the current portfolio efficient? Is this current portfolio on this efficient frontier? I think this is very obvious now after our calculation. So this will complete question 4. And for question 5, we need to graph the efficient frontier with no short sale. The graph is here, but the requirement here is to add this efficient frontier with some constraints to the graph that we made in question 3 here. So we can just add it by selecting chart design. Add X is here, sigmas, Y is here. So name is efficient frontier with no short sales. Okay, click OK. And also show here, mark the current portfolio. So select data, add. X here equals to sigma, Y here current portfolios here. Okay, so the graph looks pretty nice to me now. And the last two questions, these are short answer questions. So first, we have performed some quantitative analysis, and the rest is to provide some suggestion or advice or our analysis to our audience. So the fund has experienced big changes from 2019 to 2021. So I'll have you to read two reports. One report is the standard report of produced by Morningstar, and another report is produced by a fund analyst. So you'll get more insights about the fund and what changes they have made during this time after you have read these two files. And you also will know what is the style of the fund and what is the ranking of the fund. And summarize those changes from 2019 and 2020. The holdings, there are changes for that and also for styles. So make 3 comments about the potential of the fund. You'll get more insights after you read the fund analyst report. And finally, provide your advice for fund manager. Now for this part, the report part, you are providing your analysis to investors. And for this question, for question 7, you're providing your analysis for a fund manager. So your audience are different. So the analysis that you're producing, the comments, the suggestions will all be different. Now that the next step, I think you can start a Word file and start to answer the question.